This video is a continuation of R.4. In this video we're going to be looking at factoring perfect square trinomials. So remember, perfect square trinomials come from when I take a binomial and I multiply it times itself, or I square it. However you want to look at it. So maybe something like this. Right, x plus 7 squared and 2x minus 3y squared is when I take a binomial and I multiply it times itself or square it. And that results in the perfect square trinomial. So if I can recognize that I have a perfect square trinomial, it's much easier to factor it out. Because always in a perfect square trinomial, the two terms in the binomial, if you square them both, you get the first term and the last term. Then if you multiply the two terms together and then multiply it times 2, you'll get the middle term. So if I can recognize that it's a perfect square trinomial, it's a lot easier to factor. So I look at the first term. Is it a perfect square? Yes. What was multiplied times itself to give me that term? And that would be x. Then I look at what was multiplied times itself to give me the last term, and that would be a y. Alright, then if I say x times y times 2, that gives me 2xy. And always the sign in your answer is going to be this very first operator. The last sign always has to be a plus sign, because if it's not, then it means your terms aren't the same. So x plus 7 times x plus 7 is the same sign. 2x minus 3y times 2x minus 3y. When I multiply the last term, the signs are the same, so I should get positive always at the end. In this case, this one would be x minus y. And don't forget to put your squared up there at the top. Alright, so let's look at a couple of examples here. So we talked about the slide and divide method. Now, if you tried to do that here, you would have to say 49 times 4, and you get a fairly large number, and it may take you a little while to list out the factors. But it's perfectly fine if you do it that way. Nothing wrong with it, just a little more labor intensive. But if you can recognize that it is a perfect square trinomial, it'll save you a lot of time. So what I want to do is look at the first term, 49x squared, and determine, can I say something times itself to get this term? Now 49 can be found by saying 7 times 7, and x squared can be found by saying x times x. So this first term is a perfect square. We're going to look at the last term. Is there something I can say times itself to get 4, and that's 2, and is there something I can say times itself to get y squared, and that's y. So both of these terms are perfect squares. Now I just need to verify that I can get the middle term from them. So I'm going to say 7x times 2y, that's 14x, y. And then if I multiply that by 2, I get 28xy, which is my middle term. So this in factored form is going to be 7x plus 2y squared. Alright, looking at the bottom one. Alright, I have a plus sign at the end, so I'm okay there. I'm going to look at the first term, and then whatever that first operator is, that goes there. Alright, so let me come back up here and put that plus sign. Alright, so now I'm going to look at 81a squared b squared. I can say 9 times 9 to get 81, a times a to get a squared, and b times b to get b squared. Then I'm going to look at 25. I can say 5 times 5 to get 25. So I know that my first and last terms are both perfect squares. Now I just need to verify that when I multiply them together times 2, that I get 20. So if I say 9 times 5, I get 45, and 45 times 2 is not negative 20. Therefore, this is not a perfect square trinomial, and I can't take it any further than that. Now, you may be able to factor it in some other way, but it is not a perfect square trinomial.